Welcome to Agam's lecture series, a series of lectures designed to bring learning to the comfort of your homes. We are going to continue our discussion today on the subject General Laboratory Techniques, coded GLT 111, and we're doing part 6 of this lecture. The topic of discussion today is power systems. What is a power system? Power system is an electric power system. An electric power system is a network of electrical components deployed to achieve three purposes: either to supply, to transfer, or to use electrical power. You see them in grid systems and you see them in three-phase wiring systems. What are some of these devices that can be used in house wiring and in our in our living houses? One, let's look at the switches. What's a switch? Switches are devices used for making or breaking electric circuits. And there are different types of switches that you can see in use. One, single pole, single throw switch. In this type of switch provides an on and off position for one circuit. On position, off position for one circuit. Two, you can have single pole double throw switch. Single pole double throw switch. This switch is meant to switch on one side of the circuit. It switches only on one side of the circuit. It has three connections for it to work. One common line and one to each of the circuits to be switched. So why this one is single pole, this one is what? Double throw. It's a single pole but throws in double phases. The third one is double pole double throw. Remember, we have single pole single throw. We now have single pole double throw. We now have a double pole double throw. In this type of switch, it's used to switch both sides of the circuit. Remember, the one switches only one side of the circuit. The one switches both sides of the circuit. There is no common line for the two separate antennas. Now, what are the different forms of switches we see? Different forms of switches are in use and we see every day. We have the tumbler type of switch. This is what they commonly use in domestic wiring because it is usually very cheap. It's the tumbler type, the one you tumble up or tumble down. Tumbler type switch. You have the push button switch. Push button switch. As the name implies, you push to make and you also push to release or break the circuit. Push button. Then we have the toggle type switch. This is a one on and off switch for an equipment. You can have different equipment like TV, like a radio, like freezer. Those switches on electrical appliances are called what? Toggle switch. They are just for on and off. Then we have slider toggle. It has a toggle action, that means it has an on and off, but with a sliding process. Then we have key switch. Key switch is employed on switchboards of a telephone system where you used to have telephone landlines. We have a switchboard in the telephone office. You have a switchboard, so it has so many interconnected switches for telephone system. Then we have wafer switch. It's a rotary switch with a number of contacts. It can switch so many things on and off at the same time. Rotary switch. Then we are now looking at another device, relays, electric relays. When you go to service your car, they'll be talking about relays. Relays are operated by variations in the conditions of one circuit and serves to make or break, to make one or more connections. Relay. You either use it to make a circuit complete or to break a circuit or to make so many connections. You use it in cars, you use it in radios. They call electric relays. I have two types of these relays. We have thermal relay, the one that responds to light, and we have electromagnetic relay. Two types of relays: thermal relays and electromagnetic relays. Now, circuit breaker. What is a circuit breaker? A circuit breaker is an electromagnetic device that opens and breaks circuit automatically. It opens and breaks circuit what? Automatically. The emphasis is there, automatically. Then we used to have conduit pipe. Conduit pipe. Conduit pipe is a solid metal or plastic through which all electrical wires and installations are passed. They are normally concealed in the walls of buildings. When you see a building and the electrical wires are not seen on the surface, they are buried in the wall. They are buried because the wires are passed through conduit pipes, and these conduit pipes are buried in the walls of the what? Buildings. Then trunking pipe. Trunking pipe. Trunking pipe is a thermoset like plastic through which all cables used in networking computers are passed. When you want to network so many computers together, the pipe through which you pass all the wires and all the cables are called what? Trunking pipes. You see it in a computer office or business center where a lot of computers are networked together. Then fuses. In our houses, we have fuses, small ones and big ones. Even in cars, we have fuses, small ones and big ones. Fuses are devices that protect against electrical overload, excessive current. They are devices that protect us against and the equipment against what? Electrical overload or excessive what? Current. Whichever one the circuit provider. When there's electrical overload or excessive current, the fuse melts the fuse element and blows the fuse and opens up the series what? Circuit. The essence of that is to cut the current and protect the what? Equipment from a damage due to what? Overloading of current or excessive what? Current. There are other appliances there are other devices that we're going to look at that are used to measure voltage or current. And we listed in there. Ammeters. Ammeters. They are used for measuring amount of current in a circuit. They are used for measuring amount of current in a circuit. They are called what? Ammeters. Note the spellings. Then voltmeters. Otherwise, some people call it voltmeters. They are used to measure the potential difference between 2 points in a circuit. They are used to measure the potential difference between 2 points in what? A circuit. And you know this potential difference decides which direction current will flow. They are used to measure the potential difference between 2 points in a circuit. And this potential determines which direction current will flow. Then we have multimeters. Some textbook and some authors call it avometer. Well, in the field, artisans call it what? Avometer. But scientifically, we can call it what? Multimeter. Multi means that they are meter for measuring a lot of things. It's a sensitive meter used to measure high and low values of current. Whether the current is very high or the current is what? Very low. They are very sensitive. You can use multimeter to measure them. Then galvanometer. Galvanometer is an electromechanical device or instrument used for detecting and indicating an electric current. An electromechanical what? Device used for what? Detecting and what? Indicating electric what? Current. Thank you. If you are thrilled by this lecture, as we say, press the subscribe buttons to get the subsequent what? Lectures. I remain your lecturer, Agama. Join us in our next lecture, part 7, where we look at biological laboratory techniques, the options of biological electrical techniques. We have discussed the chemistry side, we have discussed the physics side. We are now going to discuss the biological side. Remember, the components of the basic science are what? Chemistry, physics, and what? Biology. Having discussed chemistry and physics, we are now going to look at the biological instruments and lab techniques in biology. Thank you, and God bless you.